The shape of the universe. A groundbreaking new idea about the shape of our universe has been posited, one that scientists believe will revolutionize our understanding of the universe. Our universe is vast and complex, with billions of galaxies spanning unimaginable distances. Have you ever wondered about the shape of the universe? For centuries, scientists have been trying to understand the universe's structure. In ancient Greece, philosophers like Pythagoras believed that the universe was a perfect sphere, with Earth at its center. In the early 20th century, Albert Einstein's theory of general relativity revolutionized our understanding of space and time. According to Einstein, space is not a flat, two-dimensional plane, but a curved, four-dimensional fabric that can be warped by the presence of matter and energy. While it is still an open question, recent research suggests that the universe may have a peculiar shape. The idea of a set of nested spheres, also known as a multi-connected universe, has gained traction in recent years. Imagine a set of nested spheres, with each sphere representing a higher dimension. The innermost sphere represents our 3D universe, where we live and all normal matter resides. The surface of this sphere is flat and infinite, and matches the homogeneity and isotropy that we witness in our universe. This similarity led to the suggestion that the shape of our universe may be a three-dimensional analog of the surface of a four-dimensional sphere, known as a hypersphere. The surface of the inner sphere can contain all the information about our universe. According to the holographic principle, our 3D universe can be contained in the sphere surface. This means that the surface of the inner sphere may contain all the information about the universe that we observe, including the laws of physics that govern it. This theory is supported by recent measurements of the cosmic microwave background radiation. Recent research has found evidence of a repeating pattern in the CMB radiation, which could be explained by a multi-connected universe. One article published in the journal Nature proposed a new model of the universe based on the nested sphere concept. This model suggests that the universe is not just expanding, but also rotating, which could explain some of the anomalies observed in the CMB. The cosmic microwave background radiation is a photograph of the universe at nearly 300,000 years old, and it is nearly perfectly homogeneous with a factor of 1 variation in 100,000 data points. We can calculate the properties of the third-dimension universe as of 10 to the minus 32 seconds, a tiny fraction of a second, after the Big Bang, but anything before that approaches infinity and the calculations break. This is a barrier native to the hypersphere, the edges are imaginary. The middle sphere represents a higher dimension. This dimension is governed by quantum physics, which is very different from the classical physics that we observe in our universe. Finally, the outer sphere represents the highest dimension governed by the physics of string theory, where space and time and the laws of physics are different again. The first inner sphere is the third dimension, the second sphere is the sixth dimension, and the third outer sphere is the ninth dimension, each expanding into the space-time dimension above it. So, that means the shape of the universe may be much more complex than we ever imagined, with nested spheres representing higher dimensions. It means that we are potentially living in a beautifully ordered system that expands into different dimensions above. By understanding the nested hyperspheres and higher dimensions, we may be able to unlock the secrets of the origins of our universe, black holes, dark energy, and even dark matter. Before the Big Bang of our third dimension, there would have been an original Big Bang that brought the 10 dimensions into existence. This would have started as a single infinitely compact point that expanded into the 10 dimensions with all the lower dimensions intact. According to string theory, our universe emerged from higher dimensional space, with the extra dimensions being compactified and hidden from view. The particles or strings in the 10th dimension vibrated exactly the right way to generate our matter-dominated third dimension. A group of researchers has proposed that the universe simulated itself into existence, and that there are likely multiple parallel dimensions, or third-dimensional universes that exist as a result. According to this theory, the third-dimension universe would have gone through many iterations before the current one was formed. These iterations would have involved the universe sparking in and out of existence, sometimes in tiny fractions of a second. On an infinite timeline, any arrangement of particles is possible. Therefore, it was only a matter of time before we finally reached an iteration that could support life. But what does it mean for the universe to simulate itself into existence? Essentially, it means that the universe is a self-contained system that is capable of creating itself. It's like a computer program that runs on its own, without the need for an external source. This idea is not new, it's been around for decades in the world of theoretical physics. However, this recent research has provided new evidence that supports the idea. The researchers used computer simulations to create a virtual universe that behaves similarly to our own. They found that the virtual universe created subatomic particles just like our universe, and that these particles interacted in ways that were consistent with the laws of physics that we observe. But perhaps the most mind-bending aspect of this theory is the idea of parallel dimensions. If the universe can simulate itself into existence, then it stands to reason that there could be other iterations of the universe that exist in parallel dimensions. These dimensions would be like different versions of reality, where different possibilities of the third dimension exist. The concept of parallel dimensions is not new either, it's been explored in science fiction for decades. However, this theory provides a new, scientific explanation for how they could exist. These parallel dimensions could be the result of other possibilities of the third dimension that lasted longer than a fraction of a second. Black holes have fascinated scientists and the general public alike for decades, and for good reason. They are among the most mysterious and enigmatic objects in the universe, with the power to warp space and time itself. According to recent research published in the astrophysical journal Letters, black holes may be driving matter downwards in dimensions, creating an expanding second and first dimension. This expansion, in turn, may be driving the expansion of the third dimension above it, presenting as dark energy. In a recent study, scientists used computer simulations to model the behavior of black holes and their influence on the universe. They found that the expansion of the second dimension created by black holes could indeed drive the expansion of the third dimension, explaining the mysterious force of dark energy. Dark matter has been a mystery for a long time, but with this new understanding of higher dimensions, we can start to see how it fits into the bigger picture. The dark matter of the universe can be described by higher dimensional matter, which is interacting with our universe in ways that we cannot directly observe. It has similar properties to normal matter, including mass and gravity, but isn't visible or detectable by our current technology or methods. An article published in the journal Physical Review Letters explored the idea of a fifth dimension that is wrapped around the fourth dimension, which is in turn wrapped around the third dimension. This theory could explain the mysterious dark matter that makes up much of the universe's mass. This discovery gives us new tools to explore the mysteries of the universe. By understanding the nested hyperspheres and higher dimensions, we may be able to unlock the secrets of dark matter, dark energy, and black holes, and expand our knowledge of quantum mechanics and physics.